Hello boys and girls. For this video we're going to be completing page 18 from lesson 1. Still lesson 1. It's the last page of the lesson. Let's take a look. Page 18 is just right here below me, as you can see, and the first question is based on activities that we will do in class, but you can also do them now and then we'll just go over them quickly in class. You know our time in class is very limited, so we kind of rush through things sometimes. So feel free to fill them in now. That's not homework, this page. But if you want to do it, get it out of the way. Why not? But we do have to fill out the bottom page right here. Okay, so let's start. I'll turn the camera off and we'll get started. So we're being asked to describe the patterns used in the tables in activities 2 and 3. Here's activity 2, and as you can see, here's activity 3. Okay, so let's look at activity 2 first. What is it? What patterns are we using? Well, let's see. Maria is also collecting books. She wants to make packages that have 3 fiction books and 4 non-fiction books. She already has 9 fiction books, so she has 9 fiction books, meaning if you count by threes, 3, 6, 9, okay, she wants to make packages that have 3 fiction books. So the most she can get with 9 are 3 packages, right? Because there are 3 threes in 9, if you know what I mean. How many non-fiction books will she need? Well, if she's making 3 packages, she's going to need 3 fours, right? Because she wants to make them with packages of 3 and 4. How many books of non-fiction will she need? So then what we do is we start counting. Okay, we have 3. Let me zoom in a little bit so it's easier for me to draw my numbers. Okay, we have 3, 6, 9. Oh, let me change that color. 9, 12, 15, and so on, right? And if we're counting by 4, it's 4, 8, 12, 16, 20, and so on, right? If we're going to make packages that, and please continue to fill these out, boys and girls, so you know how to do it. Do it on your own. If we're going to make packages that contain 3 fiction books and 4 non-fictions, the most I can make are 3 packages, as you can see right there. You see? Because this will be 1 packet, and then 3 from this one and 4 from this one, and another 3 from this one and another 4 from this one. So the question is asking how many will she need. As you can see here, the question is asking how many non-fiction books will she need. Well, she will need up to 12. So what pattern do we see in 2? So what pattern do we see in activity 3 as well? Let's see. Let's read activity 3. Okay, we have Sanjay has 27 jerseys. Divide them into 2 groups so that every 4 red jerseys there are 5 blue jerseys. So for every 4 there are 5. So again, we got to count by 4s because we're breaking it all up into 4s. Okay, so let's fill them out. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, clearly we're counting by multiples of 4 and multiples of 5. Now, we have to see which one is going to give us a total of 27 jerseys, as you can see right there. Okay, well, right here, when I add these 2, I'm going to get 27 jerseys. Okay, when you divide them into 2 groups, you're going to have 12 red jerseys and 15 blue jerseys to give you a total of 27 jerseys. So again, going back to the question, describe the patterns used in the table's activities in 2 and 3. Well, boys and girls, here you can write each row of the table shows the multiple of certain numbers. You can you can add or subtract these multiples to find the number. When we say you can add, it means you're counting up, or you can subtract to count down. To find the number in one group, or to find the total number in both groups. For the first one, we found the numbers in both groups, and we found that it was 9 and 12, right? And in the second one, we found the jerseys. The total number of jerseys was 27, 12, and 15. Okay, copy this down, please. If you have any questions about this, make sure you read it carefully and you understand what we mean. Or you can also rewind and watch the video again. Question 2. How would finding the least common multiple, so when you count by a number, so you count by 2s, you count by 4, by 6, by 8, those are multiples. How would finding the least common multiple help you when dividing items into equal groups? Well, think about it, boys and girls. It helps you give out a more proportional distribution. Everyone will get the same number of cookies, and everyone will get the same number of cupcakes. Think about that. Okay, let's write down a good question here. I would say that the least common multiple indicates, helps you see that the groups can be equal. And it shows the number of items in each group. So what I'm trying to say is that it would give you more proportional distribution. So go ahead and copy that down. You can pause now. As I mentioned, it allows for a proportional distribution. Every group will get the same number of let's say balloons or cookies or muffins. Okay, it allows for each group. If you find the greatest common factor to know what it'll be broken into, and then the multiples of each number, so that you know which one, how many goes into each group. Okay. Question 10. Write and solve a word problem in which there are 3 yellow beads for every 2 beads. Okay, so here's my example. Victoria has 30 yellow beads. She would like to make necklaces that have 3 beads for every 2 blue beads. 3 yellow beads for every 2 blue beads. How many beads does she need? Okay, so this is pretty much a ratio. So she wants, for every 3 yellow, she wants 2 blues, right? She has right now 30 yellows. How many blues does she need? Okay, here's a hint right there for you. Okay, here's a 3, here's a 30, here's a 2. How much should we have there? It's simply, boys and girls, a ratio, and it has to be proportional. Okay? Give me your answer right there, and that'll be a key answer. Make sure to remind me, okay? Number 11. For number 11, please listen carefully and copy this down, okay? Ready? Write and solve a real-world problem in which there are 3 tables for every 8 chairs. So every time you have 3 tables, you will have 8 chairs. Now, some of you might be thinking this is a little difficult because you have an odd number and then an even number. But no, it's not difficult. Just pay attention. Okay, let's pretend, okay, that you're going to have a party. Okay, you're having a birthday party or maybe even a wedding. And you're going to invite 40 people. Okay, you're going to invite 40 people. Now, here's my example. Please listen and write this down. There will be 40 guests, 40 people coming to the birthday party. Every 3 tables can seat 8 people. Okay? Every 3 tables can seat 8 people. How many tables will you need? Well, think about it. For every 3 tables, you have 8 people. You need to go all the way up to 40. How many tables will you need? Try to use activity 2 and 3 from the previous page, from page 16. We counted by multiples there. Count by 3s and count by 8s. When you're counting by 8 and you get to 40, the number that matches on the next row with 3s, with multiples of 3, will be your answer. Okay, I will also be looking for this, boys and girls. I'll be looking for the question and the answer. Question 12. Write and solve a real world problem, a real world word problem in which there are 3 pancakes for every person. 3 pancakes for every person. Let's see. Try to think about a problem where you have a certain amount of people and a certain amount of people each will get 3 pancakes. Maybe the question can be, how many pancakes will you need to make in total for the number of people you have? Think of that. You can write your own, or you can just simply copy this one. I know that some of you will just copy it because you don't want to try it, or even want to try thinking, which is called laziness, boys and girls. And some of you will just come up with your own because you really are interested in challenging yourself. If you do copy mine, I will not be upset. I'll just assume that you just needed a little bit more help, which is totally fine as well. Carlos is making 12 pancakes, and each person will receive 3 pancakes. How many people is he cooking pancakes for? There you go. Please answer the question. And finally, question 13. How can you use tables to relate quantities? Well, here we have a table, boys and girls. How can we use this table to relate quantities? If you are thinking that we can use tables to compare multiples, you are absolutely right. Okay, we are comparing multiples of 4 with multiples of 3. And there you have it. That completes page 18. Going back to page 17 for one sec. And on page 17, we're asked to work with a partner, right? But we'll work together. You and I will be partners. Determine the number of pieces of fruit that should be put in each group. Make as many equal-sized groups as possible using all the fruit. Use and draw counters to represent the fruit. Okay, 3 apples and 4 pears. We want to make sure that we get equal representation, proportional distribution, where we have with the 3 apples and the 9 pears. We find the greatest common factor, and the greatest common factor is going to be 3. So we can make a total of 3 groups, right? We can make 3, that's so, 1, 2, and 3, right? And for my apples, I can have 1 apple in each one, right? An apple in each one, and 3 pears in each one. 1, 2, 3, 1, 2, 3, and 1, 2, 3, right? For number 3, it gets a little tricky. We're thinking that maybe we might have to do a fraction where we do 4 groups of plums, and each one has plums, but then we got each one with 1 banana, and then only half of a banana. But nobody wants to eat half of a banana, okay? So what we can do best right here, boys and girls, this is called a relatively prime number, a relatively prime example. So really, we can't do much. We just have to make 1 basket with 4 plums and 7 bananas. Because the factors for 4 are 4 and 1. And 2 times 2, right? And the factors for 7 are 7 times 1. So the only one that they actually have in common is 1. So we can really only draw then 1. Okay, which is 1 basket, and this is a relatively prime. All right, continue on with questions 5 to 7, where you're going to use the table to solve. Okay, the multiples table.